Assalamu alaikum. Today we are solving LPP by graphical method. The question is on our screen. First we have to find out the points for each and every equation to plot on the graph. At least we have to find minimum 2 points for each equation. So here we are finding the points. We would first put x2 equal to 0 in the first equation. By putting x2 equal to 0, we would get x1 equal to 40 and the point would be 40, 0. Similarly, we have to put x1 equal to 0. In that way, we would get x2 equal to 20 and the point would be 0, 20. Actually, it's a mistake. Yeah, it would be 0, 20. In the same way, we are going to find the points of the other two equations as well. So the last point we get is 0, 20. Now we have find all the points, like at least 2 points for each equation. Now we have to plot it on the graph. While plotting on graph, we can clearly see that all the points we get are in positive. Like even if we get negative points, we are gonna ignore the negative one. Because the main concept is putting the points in the first quadrant, like the x should be positive as well as y should be positive. Yeah, so here we are taking 10 small boxes and putting a range from 10 to 40, like 10, 20, 30, 40. We can do like any other measurement as well, but here it is more sufficient for me. So that's why I took 10, 20, 30, 40 in our for our x-axis, similarly in my y-axis. So right now I'm plotting my points on the graph. First I'm plotting the equation 1 point and now I'm drawing a line that meet both the points. We have to plot each and every point and then we have to make a line between them and we gonna mention like which line is equation 1 width of equation 1 and equation 2 and equation 3. Now we have to find the feasibility region in this graph we have plotted. So to find the feasibility region, we have to look at the each and every equation we have plotted to find out, like we have to look at the inequality sign in each and every equation actually. So after looking at the signs, we get it in equation number 2, the sign we got is greater than, which indicates the outer region. Similarly, in equation number 1, we are getting a less than sign, which indicates the inner region. And equation number 3, we also get the greater than sign, which represents the outer region. So now from this point, we can clearly see our feasible region. We study the graph carefully and we got to find our feasible region that is found to be these yellow lines, the inner common part. Yeah, this part is our feasible region, and the points we are going to indicate them with these 4 points. We got the 2 points right there and 2 points right here. Now we're gonna name them point A, point B, point C, and point D. From now on, we have to find the point A, point B, point C, and point D. We can clearly see that point A, point B can be obtained easily, but for point C and D, we have to solve the equations simultaneously. So here, right down there, I'm gonna write all the points we already have and all the points we have to find with our function z, which is z equal to 20x1 plus 10x2. Now we are writing our points. Point A, that is 15 comma 0. Point B, that is 40 comma 0. Point C, which we do not actually have right now, but we are going to find it by simultaneously solving our equations. And similarly for point D as well, we have to find it by solving equations simultaneously. So now we are going to find point C actually. Here we solved our point C, and the point we got are x1 4 and x2 18. So the C is found to be 4 comma 18. Similarly, we're going to find our point D as well. So after solving our point D, we got x1 equal to 6 and x2 equal to 12. That is 6 comma 12. Now we have to put all these points in our equation, in our given function actually, the z1. So the first point, after putting 15 in the place of x1, we got z equal to 300. After putting 40 in the place of x1, we got 800. And now we have to put 4 in x1 and 18 at x2. We got 260. And now we have to put 6 at x1 and 12 at x2, and we got 240. The question was about to minimize the function. So to minimize, we have to look at the minimum value actually. So the minimum value, we can clearly see it is found to be 240. Yeah. So this was all about how to solve an LPP by a graphical method. I hope you got it well, and thank you so much.